Okay student, today our topic is register. So what is register? We have seen that a flip-flop is one byte memory cell which store one byte of digital data. A group of flip-flops stores more than one bit of digital data. So n flip-flop can store n bit of digital data. An array of flip-flop is known as register. So register is nothing but array of flip-flops which find its application in the variety of digital system. The data can be entered and retrieved in serial or parallel form. The serial form means byte by byte, sorry, bit by bit. So one bit, then after one bit, then after one bit in a serial manner. And parallel form means all bit are simultaneously and retrieved. On the basis of the data is entered to the flip-flop, it can be four type: serial in parallel out, serial in serial out, serial in parallel out, parallel in serial out, and parallel in parallel out. Register in which the data is entered and or retrieved in serial form are referred to shift registered, that is shifting the data from one side to another side. And another register is called stored register, is basically PIPO, parallel in parallel out. So data is stored in a flip-flop, in single flip-flop, and it goes to the output. So that's why it is called stored register. So register is basically two type: a shift register on the basis of mechanism shifting register from left to right, and another is stored register. So shift register can be SIPO, CISO, and PISO, and only PIPO is called stored registered. So first we go to serial in serial out shift register. In CISO shift register, data is entered and retrieved in serial fashion with clock. So for easy to handle, we generally use a D flip-flop where if input is 0 and output is 0, and if input is 1 then output will be also 1. So in serial manner, if we consider, then if we enter in a first flip-flop, that is FFA 0, then output will be 0. And as the FFB input is connected to the output of FFA, so input also 0. So in that manner the data is shifting from FFA to FFD. So if we do, or if we give input to the D terminal of FFA, then it will pass to the FFB, and after that FFC, and after that FFD. So the data is passing from one flip-flop to another flip-flop. So that's why it is called shift register, right? So this is called serial in serial out. So as it goes, or as it comes serial wise as into the FFA and it goes to the FFD. So this is serial in serial out. Now go to the serial in parallel out. So what is happening there? So if we push, or if we give a 0 to FFA, then output will be 0. And we will take data from a parallel pin, that is QA, that is QA. So in that manner we are we are taking the data on from the QA, QB, QC, QD, right? And the data is given by the only serial data, that is D terminal or input terminal of FFA, and it is showing the data on QA, QB, QC, QD. So here the data is giving by the serial manner and data is collecting from the parallel manner. So it is called serial in, parallel out. Now parallel in, serial out. This is the connection or block diagram of the parallel in, serial out. Here another thing is required, that is marks. There data is given by the parallel manner and and collecting by the serial manner. That's why it is called parallel in, serial out. And lastly, that is called stored register is parallel in, parallel out. So here data is given to the a single unique flip-flop and data is collecting from the same flip-flop. That's why it is called stored register, not shift register. Data is not shifted from left to right. That's why it is called stored register, not shift register. So here the application of shift register. The shift register are used for temporarily data storage. The shift register are also used for data transfer and data manipulation. The serial in, serial out and parallel in, parallel out shift register are used to produce time delay to digital circuit. Serial in, parallel out shift register are used to convert serial data into parallel data. Earlier we have discussed a serial in, serial out is producing time delay. Why? Because it require n clock pulses to enter the n bit and n clock pulses required to read the n bit. So n bit data process, so 2 n bit data process here require 2n number of clock, so it is delaying the system. So this is the register, and thank you. The register, shift register, stored register, CISO, SIPO, PISO, that is parallel in, serial out, parallel in, parallel out, and this 4 is the block diagram of the register. And in the next class we will discuss about the counter.